Welcome to our last module on biofeedback. This video is going to just introduce some of the physiology behind biofeedback that sort of supports the idea of biofeedback. So we go back to something you probably learned in many other classes, which is the autonomic nervous system. And the two main components that we're going to focus on include the sympathetic nervous system, and this is that response to stress. It's often been analogized to being the accelerator pedal in a car, the gas pedal in a car, something that makes us go. And then the parasympathetic nervous system is kind of that somewhat opponent process, which is the brake pedal in the car, if you want to use that analogy. And we'll use that analogy and show where it doesn't always make sense as well. And the parasympathetic nervous system is typically involved in rest and digest, routine maintenance. Another way to think of the two systems, sympathetic and parasympathetic, is that the sympathetic nervous system is an energy expending system, whereas the parasympathetic nervous system is an energy creating, restoring system. Sometimes it's also for conserving energy as well. So what's important to know for the biofeedback module is that together the sympathetic and parasympathetic nervous system regulate the heart, and specifically the rate at which the heart is beating. So a nice diagram here is hopefully going to help you understand a little bit. I'm going to make sure this is fully visible here. The yellow lines here illustrate the sympathetic nerves that innervate the heart. Here's the heart, just a diagram of the heart. And the blue is the parasympathetic nerves that innervate the heart. A couple of things that are important to notice here. Somewhat equally, they innervate, if you can remember these various portions here of the heart, the sinoatrial node and the AV node here. So both the sympathetic and the parasympathetic have control over that sinoatrial node, this SA node, which is the pacemaker of the heart. So they both have an influence on the pace at which the heart is beating. It's also helpful to recognize there's a lot more yellow, the sympathetic yellow going to the heart than you see of the blue. And you'll notice specifically, not only does the sympathetic nervous system innervate kind of the pacemaking aspects of the heart, but it also has a little bit stronger innervations here to the muscle of the heart. Myocardium, to combine some of these terms that we've had here. So the heart, the muscle itself, the ventricles specifically. So the sympathetic nervous system is often involved with more contractility aspects of the heart. Just something important to be aware of. So the parasympathetic nerve is also referred to as the vagus nerve. And again, I guess I've just labeled these here. There's the SA node, the pacemaker of the heart, and the AV node. And there's innervations to the cardiac muscle. So the way that the autonomic nervous system controls the heart, probably the typical textbook way that you've read about and you're familiar with, is this kind of reciprocal activation of the heart. The idea here is that if the sympathetic nervous system, the accelerator pedal is being pressed, if it's active, then the parasympathetic nervous system somehow by default is retracting or withdrawing. So this is where that driving the car analogy works very well. We drive a car much the way a reciprocal situation exists with the sympathetic and parasympathetic nervous system. We usually do only the accelerator or the brake, but not both at once. So I've already talked about that. However, that analogy of the accelerator brake breaks down when we recognize there's also very different ways, modes of activation between the two systems. Another one is co-activation. So actually there are times when both sympathetic and parasympathetic nervous systems are very active at the same time. So the foot is on the accelerator and the brake at the same time. So we don't typically think of this in our analogy. One way to think about this is often happens in times of extreme danger or extreme stress. And if you kind of think about a drag racer, maybe they would have their foot on both the brake and the accelerator at the same time. Maybe as they're waiting for the green light to go, they'll have their feet on both so that the sympathetic system is revved, the accelerator, the engine is revved, and when the brake is withdrawn, the system goes very fast. This is exactly what the autonomic nervous system does. And part of this is because the accelerator has a much slower response time than the sympathetic accelerator than the parasympathetic brake. Actually, the braking system in our body, the parasympathetic nervous system, is a very effective braking system. And sometimes I like to draw an analogy. The accelerating system in our body, the sympathetic nervous system, has a much slower response time. So you should almost think of it as the gas pedal in a gutless car. So if you've ever driven a car that didn't have a lot of power to it and you were trying to accelerate onto the freeway and it just kind of, you just push the pedal and it makes noise but it doesn't speed up very quickly. In a way, that's a way to think of the sympathetic nervous system. So what's also important to recognize about that is that if you need to respond instantly to a danger, and you go from 0 to 50 or 55 or 0 to 70 very quickly, your body needs to transition from a peaceful moment to sudden danger. Your heart rate will accelerate instantly, nearly instantly, and you'll feel that jolt of energy in the system, and you'll assume that was sympathetic activation, but probably what elevated the heart rate was actually, again, there's this tonic level of sympathetic activation even when we're supposedly at rest. And what probably happened is the body just took its foot off of the brake pedal. And so there was a parasympathetic withdrawal, and the revving that was underneath there, all that sympathetic tone was already, it was just released, and the heart suddenly accelerates quickly. So it's important to know how we respond quickly, and an acceleration in the heart rate doesn't always indicate straight sympathetic increase. It might well indicate just a vagal or a parasympathetic withdrawal, taking the foot off of the brake. And then there's a third way of being active in the autonomic nervous system, which is this sense of the two systems are uncoupled. One is maybe fluctuating up and down independent of what the other is doing. And I just finished my master's research, and it turned out that seemed to be more common than I ever expected to find. People were often operating in an uncoupled mode rather than this mutually exclusive system that we typically study in school. One of the other mechanisms for changing heart rate just has to do with changes in blood pressure. So if we're lying down in bed and we suddenly try to stand up, this dramatic change in posture is going to equate to a change in blood pressure, and then the arterial baroreceptors, pressure receptors in the arteries, this is an example here of some baroreceptors in the carotid artery, they will send a signal to the heart, the pacemaker of the heart, and the sympathetic nervous system or the parasympathetic nervous system will make their changes, and then they'll adjust heart rate. So they will increase heart rate. So when you first stand up, that drop in blood pressure from your head will trigger a need to increase heart rate to kind of speed up blood getting to where it needs to go.